Next up in our discussion of the evaluation of limits, we consider the evaluation of continuous functions. Now, these are the really easy ones. Okay. Um, the idea is this: a function is continuous at a point if the function value and the limit value are the same at the point. So there's no hole or break in the graph of the function at the point. So if a function is continuous at the point, and you're asked to find a limit of that function at the point, then you can just evaluate, you can just give the function value as the limit value. Okay. Um, what this means is that you should check that the function, if we want to evaluate a continuous function at x naught, it is considered to be continuous if f of x naught is defined, the limit as x goes to x naught exists, and the limit value and the function value are the same. So basically, the limit value exists at x naught, the function value exists at x naught, and they're both the same, then that function is continuous at x naught. So if you have in your mind uh, some classes of functions which are continuous, where you know where they're continuous or where they're not continuous, then where they are continuous, you will be able to evaluate the limit value very easily by simply taking the function value. Okay, so some functions are continuous at all of the real numbers on the entire real line. So polynomials, sine, cos, exponential, all of these functions are continuous at every real number. Um, some functions are continuous at lots of real numbers and not continuous at others. So for example, the tan, the cotan, the secant, the cosecant functions, those are continuous where they are defined. 1 over x is continuous where it's defined. It's not continuous at 0 where it's not defined. The logarithm function is defined for positive reals. So on the positive reals, it's continuous, and otherwise, it's not defined, and so it would be discontinuous there. Okay. So for example, we have a function reals to reals, right? The domain is the reals, the codomain is the reals. F of x is equal to 1 plus x squared. What kind of a function is it? Well, it falls in the class of polynomial functions. Polynomial functions are continuous everywhere, so we are asked, what is the limit as x goes to pi of this function? Well, it's just f of pi. Okay. Some rules for continuous functions: if f is continuous at x naught and g is continuous at x naught, then f plus g is continuous at x naught, f minus g is continuous at x naught, f times g is continuous at x naught. And with quotients, we always have to take a little bit of care. F divided by g is continuous at x naught unless g of x naught is equal to 0. Okay, so for example, we have limit as x goes to 3 of x squared plus 4 over x cubed minus 1. What kind of a function is it? Well, it's a polynomial function divided by a polynomial function. So it's a function which is continuous everywhere divided by a function which is continuous everywhere. So it will be continuous unless the denominator, it will be continuous at 3 unless the denominator is going to 0 at 3. It's not going to 0 at 3, so it is continuous at 3. Okay, so how do you evaluate the function? It's a continuous function. So just put in 3 squared plus 4 over 3 cubed minus 1. Okay, and if you do that, you will get 1/2. Okay, so we will go on to discuss continuous functions in a bit more detail later. But for now, we go on to another technique for evaluating